Assalamualaikum. So we are from group number 5 and today we will be presenting our lab report on the experiment 4, which is the application of first law and second laws of thermodynamics. These are our member of the group. So we have Nurul Azwa, Hanan Elisha, me myself, Amir Ashraf, and also Shafiq Hidayat. So for the introduction part, the first law of thermodynamics states that the heat is a form of energy and thermodynamic processes are therefore subject to the principle of conservation of energy. This means that the heat energy cannot be created or destroyed, but however, it can be transferred from one location to another, and it can also be converted to other forms of energy. And for the second law of thermodynamics, any spontaneously occurring process will always lead to an escalation in the entropy of the universe. To put it in a simple way, the second law of thermodynamics explains that an isolated system's entropy will never decrease over time. So for the objective of this experiment is we want to understand and also apply the concept of first and second laws of thermodynamics. And for the scope, we use the mass of corn oil, which is 520 gram, and then the range of temperature we use for the heating of corn oil is up to 100 degrees Celsius, and the mass of the tap water in the tank is 1827 gram. So these three are the scope that we use to do the experiment.
Assalamualaikum, my name is Hanan Elisha and I will be presenting about the theory. So according to the first law of thermodynamics, energy cannot be destroyed or created and it only changes from one form to another and move from one place to another. So from the formula Q equals to delta U plus W, no work is done in this experiment. And the change in internal energy is caused by the heat added and work done. And according to the second law of thermodynamics, total entropy will not increase over time and will not decrease over time and only increase towards a state of maximum. So clauses state that it's impossible for heat to transfer from cold to hot without work, and Calvin Planck states that it is impossible to turn heat from a place without losing some to the surrounding. And from the diagram, we can see that heat will naturally flow from hot to cold spontaneously. So in this experiment, we will observe the application of first and second law of thermodynamics between the transfer of heat from water to oil. And from here we can see that the heat that lost from water will be a heat gain for oil, and according to the Q equals to mCp delta T, when both temperature reaches equilibrium, the change in heat will be equal to 0. And from here we can see that heat will transfer from one place to another according to the first law, and heat will flow from hot to cold according to the second law. And E added is also equals to the E exit, which is an energy balance. Thank you.
So this is the experimental setup for the experiment. Firstly, we have thermometer, corn oil, hot plate, beaker holder, small beaker, stopwatch, aluminium foil, electronic balance, safety glove, big beaker and thermometer holder. So for the methodology of this experiment, firstly, 400 milliliter of corn oil is heated by using hot plate until the temperature reaches 100 degrees. Secondly, the weight of an empty small beaker and big beaker are taken on electronic balance while waiting for the corn oil to be heated. Thirdly, the corn oil is then transferred to the small beaker and the mass of the hot corn oil is recorded immediately. Fourthly, the small beaker is placed carefully into the big beaker, and then after that, tap water is added into the big beaker until it reaches the same water level as corn oil. After that, two thermometers are set up. One is into the tap water and the other one is in the coin oil by using thermometer holder. The outside of the big beaker is covered using aluminium foil. After that, the readings of both thermometers are recorded for every 1 minute until the temperature of both thermometers reach thermal equilibrium. And lastly, the mass of tap water is weighed on the electronic balance and all data is recorded in table 1 and 2.
So this is the data that we recorded before starting the experiment. This so this is table 2 that we collected the data from the experiment. The temperature of hot corn oil and water are recorded. So we can see that the temperature of hot corn oil and temperature of water reach the same temperature at 20 minutes. So we also calculate the temperature difference and energy exerted from corn oil, also energy absorbed to water. That is temperature of hot corn oil and temperature of water against time. The next graph is energy exerted from corn oil versus time and energy absorbed to water versus time. We can see that the graph of energy exerted are increasing over time and the graph of energy absorbed by water are decreasing over time. These are the examples on how we calculate the temperature difference and how we calculate the energy exerted and energy absorbed.
So for the safety procedures, make sure to wear the glove before picking up the beaker from the hot plate to prevent any unwanted accident. And then make sure that the thermometer doesn't touch the wall and the base of the beaker to prevent any inaccurate reading of the temperature. And then handle the thermometer carefully and make sure it doesn't break because the mercury inside it is poisonous. So this three is the safety procedures that we follow and obey in order to make sure that our experiment doesn't involve any unwanted accident.
For this experiment, we can relate to the first law and second law of thermodynamics. That the first law of thermodynamics stated that energy cannot be created nor destroyed. It applies to systems like power plants where chemical energy converts to thermal. Next, second law of thermodynamics show that heat moves from hotter to colder region. And lastly, no temperature changes show that thermal equilibrium was reached in the experiment.